Hello, welcome to your lesson on right triangle trigonometry. Much of this you've probably seen in geometry or algebra class, and we're going to be talking about our good friend toa. Now, if you've never heard that before, that just basically means sine is opposite over hypotenuse. That's the SOH, so toa. C is adjacent over hypotenuse, and toa, TOA, opposite over adjacent. These are ratios that are always true in a right triangle. So if I had a right triangle and I pick sides of, let's say, 5, 12, and 13, and this is a right angle here, I can apply SOHCAHTOA. SOHCAHTOA only applies to right triangles. So if you had like an equilateral triangle where you do not have any right angles, all three of these angles are 60 degrees, trigonometry SOHCAHTOA is not usable unless you use something more complicated such as law of sines, law of cosines, which we may get into later. But for this problem here, you need to identify the opposite leg, the adjacent leg, and the hypotenuse, because those are where this O, A, and H come from. So I'm going to circle in red the hypotenuse, and I'm going to put an H by it. Now the hypotenuse never changes. It's always the longest side or the side across from the right angle. In blue, I'm going to circle the adjacent and opposite. Now it depends on which one of these is which, because a lot of that depends on theta. This is a Greek symbol which means angle measure. So I could be talking about this angle here, then this is the opposite side because it's across from the angle, and this is the adjacent side because adjacent means next to, so it's next to the angle. Now if I change this to black and I'm talking about this angle, then the opposite and adjacent switch. I'll never talk about the right angle, so it'll always be one of the two other angles. Now, if I asked you to come up with the three trig ratios from this triangle, I'm going to label my angles A, B, and C. And if I want the sine of angle A, that means this angle right there. Sine is opposite over hypotenuse, so I would do the opposite side, which is 5, the hypotenuse side, which is 13. If I wanted the cosine of angle A, cosine is adjacent. This is the adjacent side, so it's 12 toa over hypotenuse 13. And tangent toa, tangent of angle A is going to be the opposite over the adjacent. So the opposite is 5, the adjacent is 12. These three trig ratios will always be the same value if this angle was a certain amount of degrees, let's say 30 degrees. If it was 30 degrees, you would always get 1/2 here. I just know that because I know a lot about trigonometry, but you wouldn't be expected to know that right now. You'd probably just plug that into your calculator. So now let's do a couple. What good is trigonometry? Trigonometry does two things for us. It finds a missing side. For example, let's pretend that this is a flag. And I needed to know the height of the flag. Well, I'm not going to get a measuring stick out here and measure how tall the flag is if I needed to replace the pole. But what I could measure is I could measure these angles through a geometric device called like a clinometer, or even your cell phones these days have little viewing angles where you can measure angles. And I could measure this because this is the ground. So I could measure the 7.4, I could measure this angle right here, but I couldn't, unless I got a huge ladder out, measure this side. So what I could use is I could use trigonometry. Now you need to decide, is it sine, cosine, or tangent I'm going to use. You looking at your triangle, I know this side and I need to know this side over here. This is the angle I know. So this is the opposite side. And the side I need to know is the adjacent side. So going back to the last slide, which one uses opposite and adjacent? It's the toa, SOHCAHTOA. So the tangent of theta is equal to opposite over adjacent. Fill in your numbers. the tangent of theta, theta is 62 degrees in this case, equals the opposite side, 7.4, over the adjacent side. I could put a question mark here, but I'm going to put x because we're used to x in algebra, and we need to solve. Now, tangent of 62 is a measurement that you can just type into your calculator if you have a scientific calculator. So you can't see this, but I'm typing the tangent button, typing in 62, and I'm getting a measurement of 1.8807. Try to use 4 decimals at least when you're using trigonometry. Equals 7.4 over x. Now I have a proportion, cross multiply. X times 1.8807, come up over here, is 1.8807x equals 7.4 times 1, which is 7.4. Solve for x, so I take 7.4 divided by 1.8807, and I get an answer of x, or question mark, is 3.9346 meters, feet, whatever your units are. That's how you do it. Using SOHCAHTOA, deciding on which one, knowing the side you need and the side you're given, and then determining that trig function, setting up your equation, cross multiply, solve. Will be useful for figuring out angles. Angle measures are needed a lot of times in the real world, such as you're shooting something up in the air, you want to know what angle to measure, to shoot it at, to hit your target, which would be way over here. So that's what this theta Greek symbol means, unknown angle. So this is my angle side using SOHCAHTOA. This is which side? Let's see, this is adjacent next to the angle, not the hypotenuse. I don't need it, nor do I care about it. This is the opposite side. So opposite and adjacent is tangent again. So that's the button I'm going to use. Tangent of the unknown angle equals a fraction 6 over 4.95. So I'm going to use my calculator. I'm going to do 6 divided by 4.95, and I get 1.2121, etc. That equals the tangent of theta. Now this is where it gets tricky, because if you have a scientific calculator, you have this tangent button, but you also have a tangent with a little -1. We call that inverse tangent. You use the tangent button to find a side, and you use this inverse tangent button to find an angle. So to get rid of this TAN word, that's why I do inverse tangent. It's kind of like taking 2x equals 7 and you divide by 2, because multiplication and division are inverses, so they cancel. Tangent and arctan, or inverse tangent, cancel each other, and you're left with theta. So then I have to do this thing on both sides the same way I divided by 2 on both sides. So tangent -1 of 1.2121. So I use my calculator. I use that tangent inverse button and plug in 1.2121, hit enter, and it gives you your angle in degrees, which in this case is 50.4768 degrees. That's how you find missing angles. Now, if I knew this side or wanted this side, then I wouldn't be using tangent. I'd be using sine or cosine depending on my other side. Last problem. Sometimes it gets more complicated than that, and you have to find a missing side. And in red, you have to find a missing angle. So I'll kind of start this one for you, but I'm not going to finish it. I'm just going to kind of set it up a little bit. So when I'm looking at the blue one, this, whoops, let's change it to blue. This is my blue triangle. If you want to redraw it, you can. I am using this angle, this side, which is adjacent, not opposite, because it's not across from the angle. And I'm using this side, which is hypotenuse, because that's across from the right angle. So adjacent and hypotenuse is ka, SOHCAHTOA. So the cosine of the angle, 20.3, equals adjacent, which is I don't know, over hypotenuse, which is 14.9. I'm going to multiply or cross multiply both sides by 14.9, and I get 14.9 times the cosine of 20.3. Cosine 20.3 in my calculator. It gives me 0.9378. 0.9378. These guys cancel. You get x. 0.9378 times 14.9 gives me 13.97. Now, the other triangle, which I'm working on in red here, I need to find an angle. Unfortunately, I don't have the angle, so I'm going to be doing inverse sine, cosine, or tangent, and I only have one side. You need two. That's why you had to do the blue triangle first, because this is going to be needed for the second part. So how do I set up the second part? It would be the hypotenuse side, the opposite side. Now it's opposite this angle, so it kind of changes depending on your triangle. So that would be sine. Sine of the angle, x with a little 2, equals opposite, which is 13.97, divided by hypotenuse, which is 17.6. 13.97 divided by 17.6 gives me 0.7935. That equals sine of this x2. So x2 is going to be whatever my calculator tells me the inverse sine of that number is. And if you want to check it, I guess I can do it real quick because this one's almost done for you. I get the angle measure is 52.53 degrees. Little bit more complicated lesson because trigonometry kind of poses some challenges. But good luck. Thanks for listening.